All right.
Do you want to
Here we
film
go.
me in
No.
John's movie?
Nope, we're done. Okay, so here's what it is recording now. So we are talking about graphing logarithmic functions. Last new topic before the test. Now, if you remember the way I taught you to graph exponential functions not long ago, this will be fairly simple. If you don't, this will probably take longer than I'd like. So hopefully you remember that. Let's actually go over that quickly here. If I asked you to just graph y equals 3 to the x, what were the 3 points that I said I was most interested in on this graph when they were Nikia?
Negative 1, 0, 1.
Were those x's or y's?
X.
X's. I was really interested in negative 1, 0, and 1. Someone other than Nikia, what y values do these x's get me, Nate?
1 over n, 1 and n.
Yep, and n in this case is 3, that's our base, so 1/3, 1, and 3. And what was, someone besides Nate and Nikia, what was the asymptote in this?
0.
0, good Kumar. The asymptote was y equals 0. So, I know this is going to look like 1/3 will be about there, 1 will be there, 3 will be up here. It's got to snuggle up to the y-axis and gradually go that way. And the points I'm interested in are negative 1, 1/3. I'll rewrite that as the coordinate 0, 1, 1, 3. Remember that? Those were good times. Here is, if you remember one word, that we've talked about just a little bit this year.
Inverse.
Go Nate. All right, Nate remembers the word. If you remember that word inverse, this is going to go pretty well.
Whoa, what?
Yeah, inverse was the right word. Yeah, go buy a lottery ticket. You're having a lucky day, my friend.
Wow.
Here's why. If I look at the function y equals the log base 3 of x, logarithms make inverse functions from exponential functions. They are the inverse functions of exponential functions. There are 3 words I don't like you guys to mix up: inverse, reciprocal, and opposite. Opposite means switch positive, negative. Reciprocal means
It's
flip the fraction, what you multiply by to get positive 1, all that fun stuff. Inverse, in terms of graphing, who remembers what inverse tells you to do?
Flip it.
Well, you can think of it as a flip and a rotation, but there's a simpler way to think of it. Not negative, that's opposite. Inverse means you do something with the x and the y.
Flip them.
change them.
I just like to say switch, but flip them and change them could work too. Yeah, those are the right idea. So what I know is,
So would be
close. Hold that thought. So my table for x equals, y equals log base 3 of x is going to be the same as the table for y equals 3 to the x with the x's and y's switched. The x is going to be 1/3 when the y is negative 1. The x is going to be 1 when the y is 0, and the x is going to be 3 when the y is 1. So my 3 points that I'm interested in on an exponential function become 3 points, the same 3 points with the x's and y's switched. That's what inverse means with functions. You switch the x's and y's. My hypotenuse, wrong class. My asymptote on the original exponential function was y equals 0. What do you think it's going to be on the logarithmic function?
x equals 0.
X equals 0. Should have done this whole table in another color to match, but
Do you actually have markers up here?
I got a couple today, yeah.
Bring some down to physics.
I do, I really do. Now I'm going to graph these 3 points, and here's my negative 1. 1/3 -1 is about here. 1, 0 is exactly there. And 3, 1 is there. So now these are the points on my logarithmic function. Any question on where I got those? Andrew, you said something interesting a minute ago.
It's mirrored.
It is mirrored.
That's what I meant by flip.
I believe you.
Oh.
No, because it was, but I didn't want to quite get into this. This dotted line is supposed to be y equals x, if I'd drawn it at a perfect 45-degree angle. Inverses are mirror reflections of each other, as long as you know that y equals x is the mirror. Okay? It's not flipped around the x-axis, it's not flipped around the y-axis, it's flipped around this line going up at a 45-degree angle.
So the asymptote always goes diagonal?
Well, this isn't an asymptote, this is just a reflection, a reflective line. If you want to draw the exponential and the inverse on the same graph, you can draw this line to see if you really got a reflection, if you did it right. The asymptote is x equals 0, which is the y-axis, which is why I had to try and draw this logarithmic function like it was snuggling up to the y-axis as it goes down here. You see how my logarithmic graph, if I go from right to left, looks like it's getting closer to the y-axis? That's because the y-axis is doing the same thing on the logarithm graph that the x-axis does for the exponential graph. This keeps getting closer and closer and closer to 0. This keeps getting closer and closer and closer to the y-axis. Everything switches the x's and y's. The points, the coordinates, the asymptote, everything. So if you remember how to graph exponential graphs, the logarithmic graphs aren't that much harder. Except I haven't dealt with like a, k, and h and all that yet. Those are the fun ones. Any questions on that before I deal with those? Going once, going twice. Everyone think they can handle this? Okay. Tyler, you want to follow me over this way?
How many views do you typically get on one of these videos?
Totally random, depends on the title. I think, because kids tend to look up things more than others. It wouldn't surprise me if logarithms, a lot of kids wanted to look up, they tend to struggle with them. Really depends on the topic. Okay, graphing logarithmic functions, next one. Here's an example of a more complicated one. So I'm just going to say y equals 2 times the log base 3 of x minus 1. Okay, do you remember me using the word parent function when we did various things this year? Okay, I'm going to do a new idea on this one. My new idea on this one is, I would say go back to a grandparent function. We're going to go back 2 generations now. And the grandparent function is, here's your definition, it's the simplest exponential function with the same base. The simplest possible exponential function with the same base as the logarithmic function we're looking at. What is the base of this logarithmic function? 3. So the grandparent function then would just be y equals 3 to the x. And this y equals 3 to the x would have the same table we had over there. So it would be -1, 0, 1 for the x, 1/3, 1, and 3 for the y. That's the grandparent function. You don't always have to graph this, but if it helps to go back to it, to remember this, please do so. The parent function, then, is the simplest logarithmic function with this base. So what would the parent function be here? Just the logarithm part.
Y equals log base 3.
Y equals log base 3 of x. You got to say that part too.
Yeah.
And then from here, you All you do in this step is you're doing the inversion. Taking the grandparent function, the child is the inverse.
Oh, so 1/3, 1/3.
We can go 1/3, 1/3 for the x's, and Kamara, what would the y's be?
-1, 0, 1.
Boom. And if this is all we were asked to do, well, we did this over there. We would just graph that one we just graphed over there in light blue. Now, the function itself, okay, there's a pattern to this. Function itself is our y equals 2 log base 3 x minus 1. Is this shift up, down, left, or right?
Down.
Down would be if it were outside the
It's
function.
right.
It is to
That would
the...
be left.
Wait, it's 2
No, but isn't it
right.
opposite?
Very good. If it's inside the function with the x, it's a counterintuitive shift. It's the opposite of what you're looking at. Literally the opposite, because you switch positive to negative. So this is inside with the x, which means two things. One, it's sideways, so this is either left or right. And two, it's the opposite. So this is a shift of 1 to the right. So what that means is, I'm going to add 1 to the parent function's x points. Okay? This is our a value. What does that tell us to do? What do we do with that on the exponential graphs? You guys struggled with that one, but Nick?
You multiply it with the y.
Multiply it with the y's.
Wait, so. Never mind.
Okay, so whatever's inside the parentheses with the x, you're going to switch the sign, and in this case, add that to these x's. The a value out here, you're going to multiply that by the y's. What if there was a plus number out here? What would we do with that?
That's the asymptote.
On the exponential ones, that was the asymptote. That'll change on the logarithm, but good memory. Good memory. That on the, I'll get to the asymptote in a minute on this one. But if there was one out here, we would add it to the y's. That would move all the y's up and down. Remember that? But I didn't give you that one yet. Okay, what's 1/3 plus 1?
1 and 1/3.
1 and 1/3. Nice simple answer. I like that. What's 1 plus 1?
2.
2. I hope everyone knew that. What's 3 plus 1?
4.
Okay, so now the points I'm interested in aren't 1/3, 1, and 3. They're 1 and 1/3, 2, and 4. Take these y's and just double them. 2 times -1 is?
Two.
Take 2 times 0,
0.
and 2 times 1.
2.
Cool. So now the points I'm going to graph is way over here still in the frame, Tyler?
Yep.
Good. Full board. Excellent. Oh, one other thing. This is a little bit confusing. The asymptote here was y equals 0, right? And like Kamara remembered, if we were adding something to the end, it would move the asymptote up or down. The asymptote here is x equals 0. Now the asymptote doesn't move up or down. The asymptote, since it's vertical, moves left or right. So the asymptote moves according to this opposite sideways shift in here. So my new asymptote is x equals 1. This number, after you switch the sign, is what gives you your new asymptote.
Which one are we graphing? All of them or just?
Just this one. I just like to go back here so I know where we started from. So this is going to be, let's take a look at it. First I'm going to draw my asymptote because it seemed to help you guys, some of you guys, to do that first because you could see what it was going to snuggle up to. Now my points are at 1 and 1/3, it's about there. I'm going to go down 2. At 2, I'm going to be at 0. And when x is 4, I'm going to be up here at +2. Now this has to look like the inverse of an exponential graph. So instead of snuggling up to something horizontal, it's got to snuggle up to something vertical. Instead of hitting the y-axis, it has to hit the x-axis. And instead of going up, it has to go to the right. Because when you switch x and y, you're switching up with right. as well as x and y. So this is my 1 1/3 -2. That's my, this is my 2, 0, right? So I have to write that backwards. And that's my 4, 2. Any questions on what I did here? Think it would help to see one more of these? Actually, I'm sorry, I'm going to do one more anyway. I want to do one where that's a little different, where there's a plus or minus something here. But before I do that, any questions on this one? You guys good? Okay. Tyler, follow me back over here. And, all right guys, you're doing really well with this. Let's see if do one more. New example. Y equals 3 times the log base 5 of x plus 2 minus 4. Think that's ugly enough for now? Without a calculator? Okay. Grandparent function. Grandparent function, we're going all the way back to the exponential function that originally spawned this horrible thing. Grandparent function, simplest exponential function with the same base. What would that be?
Y equals 2x. 5x.
Base is 5. Coefficient is 3. Okay, good. Y equals 5 to the x. My points of interest on this, the x's as usual are going to be -1, 0, 1. What are these going to be?
1/5.
Yep.
1 and 5.
Excellent. Parent function. Simplest logarithm with the same base. What's that going to be?
Y equals log 5x.
Y equals log base 5 x. Excellent, Tyler. I know that's what you meant. Please say the word base. I'm easily confused. And between an exponential and a logarithm, between the grandparent and the parent, what do we do? Just one step.
Switch it.
Switch it. Switch the x's and the y's. 1/5, 1, 5 for the x's, -1, 0, 1. Okay. Now, the function itself, y equals 3 log base 5, x plus 2 minus 4. Okay, what one thing from this function do we do to the x column? Big hint. Subtracting what?
2.
Subtracting 2, Stephanie says. Everyone agree with that?
To the y, that
To the x.
2x, yeah.
Nope, for this one I have, I got this right. That's what we did over here.
Oh.
Right. On this one,
right.
yeah,
Okay.
whatever's inside those parentheses with the x, whatever's also inside the logarithm function, that we do the opposite of that to the x's. Okay, now the y's, wrote that a little too soon. Everything else goes to the y's. If it's not in there with the x, we ignore it. Okay, so everything else goes to the y's. So we're going to multiply the y's by 3, and we're going to subtract 4 from them. Okay? The asymptote on this one is y equals 0. That's on our exponential function. It's horizontal. The asymptote on the parent function, our logarithmic function, is x equals 0 because we're switching everything. What of these 3 changes we have? The a in the front, the horizontal counterintuitive shift, the vertical intuitive shift. Which of these things now applies to our vertical asymptote? That's, Nick, that's what you're thinking back here on exponentials. The -4 moved the asymptote up and down on the exponential functions, but on the logarithmic ones, which one, Nikia?
The one that is in parentheses.
One that's in parentheses, do we keep the sign or change it?
Change it.
Flip it. Always check the opposite of whatever's inside the function. So this asymptote is x equals -2. Okay? It's always what's inside here when you're talking about logarithms. It's what's outside here when we're talking about exponentials. Okay, fraction review. What is 1/5 minus 2?
Negative 9/5.
Isn't it negative 7/5?
No.
Because it's 1/5. Double checking.
It's
if you're
actually
good at
1
this.
4/5.
But it's negative,
Yeah, negative 1 4/5.
which is the same thing as negative 9/5. You are correct, I am wrong. I was brain farting. Sorry. Okay, thank you. You're both correct. So I'm going to go with negative 9/5 because that's how I was thinking of it first, which is also negative 1 4/5. Slightly easier. What's 1 minus 2?
Oh,
Negative.
Negative 1. Is there anyone here who would struggle to find what 5 minus 2 was without a calculator?
nope.
3.
3.
3. Thank you for no one calling out the wrong answer there. All right. What is 3 times
Negative 7.
negative? Well, it's yes, it is. Okay, I'm just gonna roll with it because we're running out of time. Thank you, Tyler.
Negative 4.
May I write the step?
Okay.
Thank you. So that's negative 4,
I get excited about
and
it.
then
Negative 1.
3 times 1 minus 4 is negative 1. No, I like that. Stay excited about it. That's fantastic. Okay, so graphing this one.
Wait, that's so weird.
Which one?
Oh, never mind. Oh, okay, I was confused for a second.
That's okay.
Double check me though, because obviously I was struggling too.
No,
So.
I did something wrong.
Okay. Okay, so I'm going. First thing I like to draw is the asymptote. That helps me get the shape right. Some of you guys struggle to make this look like a curve. And remember, if you get one point wrong, it doesn't look like the kind of curve you want. You want a sideways exponential curve. My points are, okay, negative 9/5 or negative 1 4/5. That's about there. And then from there I go down negative 7. 1, 2, 3, 4, 5, 6, 7. So that's around there. Negative 4, 1, 2, 3, 4. That's at negative 1. Yeah, negative 1, negative 4. And then over here at positive 3, remember you can switch your scale from x to y, but you have to keep the same scale on the x and keep the same scale on the y. And at 3 we're at negative 1, so that's there. It's the y-axis somewhere in between these two. Has to look like it's getting closer to that asymptote. And here are my points, negative 9/5, negative 7, negative 1, negative 4. Am I writing this correctly? Double check me. And 3, negative 1. You guys think you can handle that?
Mm-hmm.
I did graph those correctly?
Yes.
Yep.
Okay. Incidentally, it looks for my drawing like the x-axis is going to turn out to be an asymptote. It won't. This will eventually cross the x-axis and just keep going up. It will not keep snuggling up close to it. But on this drawing it looks like it, but that won't happen. I don't know for sure that that's where the y-intercept is either, but we're not going to worry about the y-intercept yet. So just make your best drawing on that. That'll take care of itself for now. Okay, I'm going to give you the worksheet that the homework is on, that has the homework on it, and that should be it. Kill it.